All right. Okay, so we're doing 7.5 today. So everybody is with me. Everyone has their notes. We have learned, or we at least spent 2 days on 7.4. And so um, we, I'm sorry, I got distracted. We had spent 2 days on 7.4, and today I'm teaching you two new theorems that go with the ones from 7.4. So we did heartbeat and swoosh last week. Today we're learning something called side splitter, and then triangle angle bisector theorem. So these are two more ways to write proportions. If you are having a hard time with heartbeat and swoosh, you need to get help as soon as you can. And if you choose not to listen to this or do not retain what you need to, you have to get help immediately too. There are only 2 sections on this quiz, so if you can't do any of these theorems and set up proportions, you will not do well in the quiz on Friday. I'm just giving you a heads up. You have to take ownership. You have to take responsibility for this. So make sure that you know what you need to know before you go to this quiz. Okay. So we're going to start with side splitter theorem, and it's talking about these lines that are parallel in a triangle. So if a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. I'm going to zoom in on this guy, and I'm actually going to label these sides different things instead of the 2 letters. We're just going to go a little letter. So I've got little a and little b for the sides that are parallel. I've got little c for qs, little d for sy, not qy, just sy, this little bitty part at the bottom. And then I'll call qre, and I'll call rxf. I'm just going to match this proportion that they told us will equal if I know that little a and little b are parallel. I've got f over e is going to be equal to d over c. F over e equals d over c. So I did small over bigger and then small over bigger. Now, this is not the only way. There's a bunch of different ways to write the proportions. You could also do like just flip this and do not e on top, e over f equals c over d. So you could flip those. That's okay. Another way kids in my other class were writing it is they did like both the tops together. So they did like e over c equals f over d. And then just flipped that to c over e equals d over f. So both of these are ways that work. These are all 4 different proportions that say the same thing. And the reason I know that they say the same thing is when I go to cross multiply, f times c, f times c, f times c, f times c. We're doing f times c each time, and then we're also multiplying d and e together each time. So it doesn't matter which proportion you set up because you're going to get the same answer when you cross multiply. Now, this only works for the sides that are intersected by the parallel lines. It does not work for the parallel sides. So I'm going to do a little notability magic and remind us about something you learned back in 7.2 or 7.3, excuse me. In 7.3, we talked about similar triangles. And so if I'm trying to do something with the sides that are A and B, I have to use similar triangles. So I just copied the little triangle. I've got Q, R, S. We know the bottom is A, R to Q is E, and then Q to S is C. And then now I'm going to do the big triangle. Oh, that was kind of trash, but that's okay. This is the big triangle. It's QXY. So it's the entire shape, not just like the little trapezoid at the bottom. It's the entire triangle. And so that bottom side is B, but then its side is not just C or D, it's C plus D. And the other side is not just E or F, it's E plus F. The reason I'm bringing this up is because these 2 shapes are similar. They both have Q that they share as an angle. And because A and B are parallel, then angles R and X are congruent. And then also S and Y, I don't have to label those. But these triangles are similar by A similarity. You cannot do side splitter with your parallel sides or parallel lines. but we can use our similar triangles in order to solve for A and B. Okay. Anybody have any questions so far? We're going to use these proportions to help us find everything else. So I'm going to set up the first one. I've got this shape. I've got these triangles. I'm going to do my side splitter theorem because I see two parallel lines. I'm going to do 6/18 equals x plus 2 over x plus 22. Six over 18 equals x plus 2 over x plus 22. Anybody have questions on how I set that up? I need to cross multiply. I've got 6 times x plus 22, 18 times x plus 2. I'm going to distribute 6x plus 132, I believe, equals 18x plus 36. I'm going to go through the algebra pretty quick today just because that's not the point of the lesson. If you can't get from the proportion to the final answer, you got to come see me sometime outside of class because I assume you already know that. That's not like little things we learned during the pandemic from Algebra 1. Like this is basics that you learned a long time ago. So if you struggle, it's okay. You got to get help though, not during class. Minus 6x minus 36 divide by 12. And so x is going to equal 8. Set up your proportion, cross multiply, distribute, combine like terms, solve. Anybody have any questions on the first one? Okay. The next one says, determine whether BC is parallel to DE. I've got this shape, and I'm going to label it really quick, and then I'm going to need help setting up a proportion. So if these lines are parallel, then that means my proportion is true. It's like a true statement. I can cross multiply and get the same thing. So let me label first. I've got AD is 15. I've got DB is 12. I've got AE is 10, and I've got EC is 8. Okay, and I'm kind of wondering, are these lines going to be parallel? If they are parallel, you can set up a side splitter proportion like we just learned. Who can write one for me?
I can.
Go ahead, Ava. I see your screen lit up.
So I put 15 over 12 equals 10 over 8.
Perfect. 15 over 12 equals 10 over 8. 15, 12, 10, and 8. You could have written it differently. You could have done 15 over 10 and 12 over 8. That is fine. You could have done, I don't know, 10 over 8 equals 15 over 12. There's a lot of different ways to write it. Either way you do it, though, you should end up multiplying and getting 15 times 8, which is 120, and 12 times 10, which is also 120. Oh, shoot, look, they're the same. When they're the same, that means it's a true statement. That means the proportions are equal. That is true. And so these lines are parallel. So I'm going to write yes, DE is parallel to BC, and it's because sides are proportional. Okay, anybody questions on that? All right, keep moving. Oh, I got 2 over here. All right, let's zoom in on the top one. Find the value of x. We got this shape and all I have is x. Oh, I'm going to argue this isn't a side splitter. This is something different. Do we know what segment x is? What's the name of that special segment?
A mid-segment. It's a mid-segment.
Mid-segment. I heard that from a ton of us. So that means a lot of us remember mid-segment. I see that it's midpoints over here because this segment and this segment are congruent, which means it's split by a midpoint. Same over here. If I didn't know, I am going to write mid-segment right now. I also know and was told that mid-segments are parallel to each other. But now I need to remember, what do I know about like the distance of the mid-segment or the length of the mid-segment?
It's 1/2 of the bottom one.
It's 1/2 of the side opposite it. So the mid-segment is equal to 1.
Yeah, that's what I meant.
1/2 the opposite side. So x is equal to 1/2 35. 1/2 the opposite side. 1/2 of 35 is 17.5. That's it. So that was something we learned back at the beginning of January, what feels like a long, long time ago, but is still relevant. We still have to remember it. All right, so that was just a quick reminder of something we knew before. Any questions so far? All right, and I've got another one here before I find a new idea. Okay, before I set this up, I need to know the length of this segment right here. What would that be?
22.
Okay. Now I need a proportion. Somebody I haven't heard from yet, give me a proportion for this shape.
X over X plus 12 equals 11 over 22.
Awesome. Very good, Maddie. X over X plus 12 equals 11 over 22. Very good, very good. We knew that we had to do the small side and then the bigger side on the same one, and then 11 over 22. You could have rearranged this a couple different ways, but at the end of the day, when you cross multiply, you should get the same thing that we're about to get from Maddie's equation. 22 times x is 22x. I'm not going to distribute that 11 to my x plus 12 until I write it down, just in case I mess up. 11 times x plus 12, distribute that. 22x equals 11x plus 132. Again, I'm going to go through the algebra pretty quick. If you have a question, let me know. I'm going to minus 11x on both sides to get 11x equals 132. And then I divide both sides by 11 to get x equals 12. Those are a lot of the same numbers, but it works out. And if we were to put 12 in for x, we could still solve that proportion and it should be the same thing. All right. Any questions on the side splitter theorem? You don't have to fully get it yet because we're still technically doing it. The next new thing, I guess, is called the corollary to the side splitter theorem. Corollary is like theorem light. It's kind of like a theorem, but it's not enough new information to be its own theorem. It just kind of, rides the coattails of a different one. So this is the exact same thing as the side splitter theorem, but instead of it all being triangles, so everything we've looked at before has been triangles with parallel lines. Now I just have 3 sets of parallel lines and they make the same ratio or proportion of their sides as a triangle does. So if little a, little b, little c are all parallel to each other and they cut these transversals, then the sides that they cut become proportional to each other. So again, let's name them little letters. We're going to call this one little m. We'll call this one little n. We'll go over here and call this little p and this one little s. Again, I just think it's easier to use one letter instead of 2. Okay. So we can do our proportion as m over n and p over s. Again, just like before, there's a ton of ways, so I'll do the flip of these. Instead of m over n, you could flip it and do n over m, which would then give us p, and s would be flipped again too. So those are okay. You could also do the 2 on top together. So I could do m over p equals n over s. And again, you can flip that to be p over m equals s over n. It does not really matter to me. And you don't even have to write all these options down. I just want you to know, if you write something down, but somebody in class volunteers a different answer and I say that that's fine, it doesn't mean yours is wrong. Wait till you cross multiply. And if you're cross multiplying and getting the same thing, then you're fine. If you're not, and you're confused as to why you're always getting it wrong, come talk to me because it's a simple fix. I just want to make sure I know where you're coming from before I tell you whether you're right or wrong. All right, so we're just practicing more side splitter, except instead of 2 triangles, I just got these parallel lines, but it's the exact same method. So in this shape, I need to set up my proportion. So somebody I haven't talked to yet, what would my proportion be here?
12 over x plus 12 is equal to 3 over 5x, or 3x over 5x.
Good. 12 over x plus 12 equals 3x over 5x. Very good, Gwenna. So Gwenna did both the ones on the bottom, and then she jumped back and did the 2 on the top. Awesome. Let's cross multiply. That gives me 3x times x plus 12 equals 12 times 5x. Distribute 3x in, so I get 3x squared plus 36x equals 60x. Now, once you get here, you might be like, oh, I don't really know how to solve for x because everything has an x. Well, what I would do is move everything to one side and factor. You might think this looks a lot like quadratic formula, and it almost does, but there's no constant at the end. So I'm just going to move my 60x over. So I get 3x squared minus 24x equals 0. And my factoring here is just a GCF. So think like what can go into 3x squared and negative 24x? And that's 3x. Divide 3x squared by 3x, you get x. Divide negative 24x by 3x, and I get negative 8. Now, factoring, I know we spent like a lot of time on this a few weeks ago, and then since then we haven't spent a lot of time there. That's still a tool in your toolbox. So I can give you all these problems like this, and now that we've gone over factoring, I expect you to know how to do it and to look to do it in these types of problems. From here, I would say, okay, x equals 0 and x equals 8. However, I'm not going to use 0. If I plugged 0 in for 3 times 0, 3x, that's 0. There's no segment length there. I'm going to cross that one out, and I'm just going to say my answer is x equals 8.
I did something different and I still got 8.
Did you move the x's together and the x square on the other side and then divide by 3x or something like that?
Yeah, I ended up having like 24x equals 3x squared. So I just divided by x and I got 24 equals 3x, then x equals 8.
And that works in this case. I'm going to warn you when you get to algebra 2, sometimes you want that 0 as an answer, so be careful with that. Sometimes it's better to do this way, but at the end of the day here, 0 doesn't make sense in our answer, so that works for us. Good job, Gwenna.
Miss White. For that one, I got 2 square root of 2. Because like instead of like equaling it out to 0, I like did minus 36x to the 60.
You still should have gotten like 3x squared equals.
Like I got square root.
You got like
I got square root of 8.
Right. But if you forgot that there was another x with the 24, so like you could have gotten rid of the x instead of just square rooting both sides.
Okay.
So I think you lost your
Okay,
x.
thank you.
So be careful on that one. We don't do a lot with those, but I wanted to do one example at least so we could kind of talk through that. I am going to skip this middle one, and we'll do that when we do review all in class together. So for sake of time, we're just going to skip to the last one. Again, someone I haven't talked to yet, can you write my proportion for me?
I can.
Go ahead, Maggie.
5 over 8 equals y over y plus 2.
5 over 8 equals y over y plus 2. And again, there are several ways you could write it. So even if you didn't write it the same way Maggie did, make sure when you cross multiply, 8 times y is 8y, and then 5 times y plus 2. As long as you get to this step, your proportion is fine. Distribute that 5 into my y and my 2. So I get 8y equals 5y plus 10. And then I'm going to minus 5y from both sides to get 3y. And I'm going to divide by 3, and I'm going to get y equals 10 over 3. You can make that a decimal if you want. I don't have my calculator that close to me. And I wanted to do this example to show you it's okay to get a decimal. It's okay to get something that doesn't work out nicely. All right, that was all side splitter theorem stuff. Does anyone have questions on that type of proportion setup?
Hey, Miss White.
Yeah, Abby.
So like for this question, if I didn't do like 5/8, could I do like 8/y+2 equals 5/y, and would that still work?
That should work. So you said 8/y+2 and then 5/y.
Yeah.
Mhm.
Okay.
A good question. So Abby just brought up the point that you can have a different proportion. You should start to get the same step as we do right here. So you can kind of check yourself. Even if your first step isn't right, your second one should be right. And there's a ton of different ways you can write it. So we might not all even have the same response. All right, any more questions before I flip to the back? All right, go ahead and flip your paper over. This is the second theorem for today, and it's the fourth theorem overall. So I want to kind of take a minute to pause, team timeout, and go over the things that we've talked about so far. That's like fair game for the quiz. So the first two theorems kind of went together. So I'm going to write heartbeat and swoosh together. Those happened in the same type of triangles. Those were both in right triangles and ones that had an altitude. So that was 2 days of 7.4. One was a video that you watched, and then another one was us in class, and we spent a long time going over it, practicing it, etc. Those only happen in right triangles and with altitudes. The one we just learned was my side splitter one, and that only works when there are lines that are parallel. So there were no right triangles that we were just dealing with. We just had parallel lines. There's no altitudes. There were parallel lines. There were some mid segments. That was okay, but mostly it was just parallel lines. The last one I'm about to teach you, I think, is like the most like common sense one or most intuitive one, because it's called the triangle angle bisector theorem. And that only works when you have an angle that is bisected. So it's named literally what you see. So this theorem says if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So like the angle bisector is happening right here at angle A because it's marked two congruent angles next to it. And again, I'm going to label these other little letters. We'll call this like X and Y, and we'll call this P and Q, just so I can rewrite our little proportion. Now, I'm going to read what they have written here and rewrite it, but then I'm going to tell you one that I think makes way more sense in my head, at least. So it says CD over DB, so that's Y over Q, equals CA over BA, which is X over P. I find that kind of clunky to do because I'm like going one direction, I'm coming back, and I'm going up, and then I'm going up again. Like it doesn't connect. However, I like to think of these as like two little peace signs. So like I think about like a peace sign here and a peace sign here that come together. So like I would write this proportion, and it's the same as this one. It doesn't truly matter. I'd write it as Y over X. That's like a little peace sign. Equals Q over P. Y over X equals Q over P. In both of these, I'm still doing X and Q multiplied together, and I'm still doing Y and P multiplied together. It's the same thing, just like the other ones were. You could even go from top, you could do X over Y equals P over Q. It truly doesn't matter. I just do think it's easier to do like the two on one side of the angle bisector together, and then two on the other side of the angle bisector together. Okay. Now I've got, we're going to skip this last one for today. Don't cross it out, just don't write on it. We're going to do two of these examples, and then we're going to do one of the final examples, and then we're going to be done for today. I'm going to do this first one. I've got this triangle right here, and I'm going to do, since I see an angle bisector, I'm doing my little P sign, my angle bisector theorem. So I'm going to do 20 over 25 equals 28 over X. 20 over 25 equals 28 over X. Anybody have questions on how I wrote that? Okay, I'm gonna cross multiply. I get 20x equals 700. And then I divide by 20 and I get x equals 35. Any big questions so far? Okay, let's look at the next one. I've got the same idea, but before I solve, I need to know what that little segment is. How much is that?
5.
5. And then I've got an angle bisector right here, so that splits the shape into 2 little pieces with the angle bisector. So someone I haven't talked to, give me my proportion.
5/13 equals 10/x.
5/13 equals 10/x. You could also go the other way. X/10 equals 13/5. Again, lots of ways to do it, but this is perfect. Good job. Anybody have questions on how Bethy set up her proportion? Okay, let's cross multiply. I get 5x equals 130. And I divide by 5 and I get x equals 26. Again, we're going to hold the other one for tomorrow. We're going to do one of the ones at the bottom because it's a little bit longer. And it actually wants us to remember something back from 7.3. So before I get to that last one, does anyone have any questions so far? No? Okay. This last one, it says using the side splitter theorem versus using similar triangles. Okay. I can use side splitter to find y. I can use my sides. I can set that all up. That's all fun and games. However, I cannot for x. So if you remember above, I made it a little bit of a deal about how this side splitter does not work for the parallel sides. So if you're trying to find x, you don't get to do side splitter because x is not part of the ones that's split by the parallel lines. It's not a side splitter, it's one of the parallel lines. So we're going to have to look at similar triangles. Before we do that though, let's find y. Can someone set up a proportion for me to find y?
Y/30 equals 16/20. Would that work?
Y/30 equals 16/20. That does work. So we did these two, we did those two. Very good. We also could have done y/16 equals 30/20, lots of different ways. Again, if you wrote a proportion that doesn't match what we did, let's wait, let's cross multiply. When you cross multiply, I get 20y equals 30 times 16, which is 480. And then I'm going to divide 480 by 20, and I should get y equals 24. So even if you set up a different proportion, you should still get 24. Okay, so we just learned that. We just practiced that a bunch. We just did it again. Anybody have questions on how we found y? Okay, now we have to find x. And before I ask for a proportion, I'm going to do my notability magic and I'm going to redraw my triangles. I just did the small one, so this bottom part's 18, the flat part's 30, and that like diagonal is y. Now I'm going to do the other part. Whatever, it doesn't matter that much. And this time I know the bottom's x, but the side is not 20. It's not like the little trapezoid. I didn't draw that. I drew the entire big triangle. So it's going to be 20 plus 30, which is 50. And then the other side is 16 plus y. Now we actually do know what y is. Y is 24 in both of these cases. So I can rewrite that as 24, which means that this entire like diagonal side of the big triangle is 40. Again, we did this a lot back when we did our similar triangles. Can someone set up an equation for me to solve for x?
(18/30 equals x/50.
18/30 equals x/50. 18 over 30 equals x over 50. Yep, very good. I just had to repeat that a couple times because again, there's a lot that you could do there. You also could have used the 24 and the 40. So we could have done 18 over 24 equals x over 40. A lot of us chose not to use that side, at least in my other classes, just because we knew y was 24, but we didn't think to use that actually in action. We just kind of plugged it in and left it there. But this is totally fine. You could also do 18 over x and 30 over 50. Lots of different ways for you to write this. But again, as we cross multiply, I get 30x equals 18 times 50, which is 900. And then 900 divided by 30 is 30.
Miss White,
Yeah.
why can you not just do 18 times 2?
Great question. So Maddie's thinking of mid-segment stuff. The reason we cannot do that is this is not a mid-segment because this is not a midpoint. If these two sides were the same, we could 100% do that, but these are not congruent. So this is not a midpoint, and that means 18 is not a mid-segment. I love that thought though. Does that answer our questions? Okay. Any other questions on this problem? Any other questions on the whole page?
My internet was cutting out when you answered Maddie's question. So how do I differentiate when it's going to be a mixed segment or not?
Good question, Gwenna. So Maddie's question was asking, could we treat this as a mid segment? And I said no, because this is not a midpoint. This point right here is not a midpoint because these segments are not congruent. If they were both 20 and 20 or 30 and 30, then I would say go right ahead. 18 times 2 should give you that number. And then these two numbers should also be the same too. And if that's true, we can go ahead and use that. But since I saw that one was 20 and one was 30, I know that it doesn't work that way.
Thank you.
Welcome. I do love that we're trying to use our toolbox and you guys are like, oh, I know all these other things. I want to try and connect it. And we did connect it earlier, but here we don't get to. So we'll just keep trying and maybe again, we'll be able to connect those kind of dots later on. Okay, any other questions on this note sheet? Okay, one thing before we all sign off, reminder that you do have homework. It is not due until Wednesday because that's the next time I see you. Oh, that's not what I wanted. Your homework is called 7.5, and I will make a Dropbox right now. You have to show work. You have to show a proportion. You have to set up an equation in order to get full credit for it. I let it kind of slide the day that you watched a video on this lesson, but if you just have x equals all over this paper, no, I don't want it. The quiz is on such small amount of material that if you don't know how to do this or you don't know how to set up the proportions, it will not go well. So if you're going through this and you're like, I don't know how to do this, you got to get help from me. Wednesday morning, Thursday morning, or after afternoons or evenings via Zoom. I'm here to help you, but
Mrs. White,
Max,
when is the quiz again?
it's on Friday.
Friday? Okay, thanks.
Friday first thing. And I'll remind you again on Wednesday, but if you're not going to be here on Friday, you got to get this quiz done on Thursday. We got to get it done before you go on spring break. All right, well, I'll be around if anyone has any questions. If not, have a good rest of your day and I will see you guys later.